We are starting a chapter about polynomials today. We're going to be graphing polynomials. We have been graphing quadratics, which are polynomials, but we haven't graphed a lot. So we're going to be, that's what our entire chapter is about, is polynomials. All right, so just as a review, the definition of monomial. What's mono mean? One. What means two? So a monomial has one term. The variables are only in the numerator of the term. The exponents on the variables are numbers greater than or equal to 0. All right, so monomial, it's one term. The variables in that term are only in the numerator of the term. That means they're not in the denominator if it was a fraction. And the exponents on the variables are numbers that are greater than or equal to 0. And then you probably have run out of space up there, so I'm going to put the definition of polynomial just down here. Polynomial. Polynomial. It's a collection of those monomials, of those terms, put together with addition or subtraction. A polynomial, the terms are separated by addition or subtraction. And then in this chart is some vocabulary and some examples, and then we're going to add some more vocabulary off to the side once you get that copy down. So let me scroll it, sorry. We're in the back, there you go. Polynomials are your favorite, okay? I just tell. Bob Bailey. Okay, so here's some vocabulary, and right in the middle is standard form, and we have done standard form when we did quadratics. Standard forms like ax squared plus bx plus c, where the x squared is first, the x is in the middle, and then that c is that constant on the end. Here, they've just written a slightly different way where they don't have a, b, and c. They have like a2, a1, and a0. That could mean the same thing as like a, b, and c. They're just three different numbers. And then they also have standard form for other kinds of polynomials. So the first one would be a constant, where there's no x's at all. It's just a number. The second one, there would be an x to the first power, and that would be called linear. The second one we've done x to the second power, and that's called quadratic. Then we get to the third one, which we haven't done a lot of yet. Notice that you look at the exponents, and the highest exponent is a 3. If that's the case, we call it cubic. The fourth one, the highest exponent is a 4, and we call it quartic. There are other names that we're not going to write down. But you're more than welcome to look them up on the internet if you're curious. This degree over here, this degree comes from the first term, the exponent on the variable. The highest exponent on the variable. That's where the degree comes from. So you'll see it matches, like cubic, the degree is 3. Quartic, the degree is 4. It matches that first exponent when it's in standard form. Okay, and then over on this side, we've got some examples of functions that are each of those kind. And if we have the first one, f of x equals negative 14, that is a constant. That has one term. This is what we're putting over in the box. If it has one term, what do we call it? A monomial. Yeah. Has one term, we call it a monomial. The second example, the linear question. The example. 5x minus 7. F of x equals 5x minus 7. How many terms? 2 terms. And if it has 2 terms, what do we call it? Binomial. A linear function does not have to have 2 terms. It could have 1 term. This is just an example. What makes it linear is that the x is to the first power only. That's what makes it linear. It's not the number of terms. So then here's an example of a quadratic. F of x equals 2x squared plus x minus 9. How many terms? 3 terms. Terms are separated by plus or minus signs, and we call it a trinomial. We've been using this vocabulary, we just never wrote it down. All right, again, quadratic does not have to have 3 terms. It can have 1 term. It can have 2 terms. That's just the example that they put there. So looking at the cubic, x cubed minus x squared plus 3x. How many terms?
3.
The example has 3 terms. So we call it a trinomial. And then we've got the quartic, the 4th degree, the quartic. We've got x to the 4th plus 2x minus 1. How many terms? 3 terms. So that's also trinomial. What is it called if it has 4 terms? It's called a polynomial if it has 4 terms. What's it called if it has 5 terms? It's called a polynomial. What is it called if it has 6 terms? It's called a polynomial. They just don't get any special names. Sorry, not special. Okay, these 4 examples, I'm going to go through the process. You're going to write down the words so they get something to look back on. The directions say decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. So we look at the first one, negative 2x to the 3rd minus 5x plus 8. Is this a polynomial function? So look at each monomial. Let's just wait till we get to the calculator. Oh, wait. Somebody like threw in the hallway?
He's outside.
Not knocking?
He doesn't want to. I don't know why.
He's red. Yeah. Well, it is. All right. For question A, is that a polynomial? Look at each monomial, and we have to decide if it follows the rules where the exponents are the variables are only in numerators, and they're only to powers that are 0 and above. So this one is a polynomial. So what would standard form be for this polynomial? Standard form would be as long as the exponents are going in descending powers, which it already is, so you could just recopy it, or you could say it's already in standard form. And then we have to state the degree, the type, and the leading coefficient. I abbreviated those with abbreviations that aren't really valid. The degree is 3. Got it. That means the type, if the degree is 3, the type is cubic, and the leading coefficient is -2. The leading coefficient would be the first coefficient. Remember, coefficients are just the numbers in front of the x. Numbers being multiplied by the x, I should say. All right, next one. Is it a polynomial? The answer is yes. It's not in standard form yet, so we look through in which term has the highest exponents. Square root of 2, x to the 4th. And then the next highest exponents, or the descending powers from there, would be minus 0.8 x to the 3rd minus 12. So that would be in descending powers of the exponents. So our degree of this one, yes, Elsie?
Is the square root sign only over the 2?
It's only over the 2. And I felt like that was kind of confusing, because we should write it as this. That would be the proper way of writing it. But yeah, it is only over the 2. Okay, so is this polynomial? Yes, there's standard form. What is the degree? 4. So that means it is a quartic. And the leading coefficient? Square root of 2. Okay, next one. Is it a polynomial? It is not a polynomial. So if it's not a polynomial, let's explain why. It is not a polynomial because exponents on variables must be greater than or equal to 0. So the exponents cannot be -1 on the variable. They can be -1 on a number. They can't be -1 on the variable. So then you wouldn't have to answer anything else, because it's not a polynomial. How about D? Is it a polynomial?
No.
It's not a polynomial. Why not? Right, because we can only have numbers in the exponents. We cannot have the x in the exponent spot. So there are 3 student practice. Take a moment, try it on your own. All right, guys, do you turn the page? Next one, evaluating a polynomial function. I'm going to model what I would like to see on your paper if I were going to grade anything from you. I'm going to model what I would like to see from you. This says evaluate f of x equals 2x to the 4th minus 8x squared plus 5x minus 7 when x equals 3. What does that mean to do? Plug in x equals 3. So every place that you see an x, you're going to plug in 3. So we're going to write f of 3 equals 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. And then I know you know how to plug stuff in your calculator. Okay, I know that. I just want to make sure that everybody understands what this means. So I don't really care. I mean, I know you can totally plug this in your calculator correctly. I'm not going to spend time on that. Let's spend time on what does that mean. You know what I mean, Nick?
Yeah, does it mean that whatever is not counted is what you plug in?
Yes, that's what I plugged in. What's the F mean though? Good. So this you're about halfway there. this is the value of the function when x is 3. That's what that means right there. And the sooner you can practice over and over again, learn what f of 3 means, it's going to make your work a lot easier once you know what that means. We were doing things with f of x before. What's another way we can think of f of x when we do a graph? It's just y. So what we're doing is we're finding what y is when x is 3. That's what we're doing right here. We're finding what y equals when x equals 3. That's what we're doing. So when you give me the answer, you're giving me what y equals. And just a hint, for those of us that are not very good at order of operations, unfortunately you're sophomores and juniors in high school right now. I don't have time to teach all that. You're not very good at order of operations. Your calculator does order of operations for you, as long as you type it in correctly with the parentheses in the right spot. So if you do, just type all that in your calculator. It should give you the right answer. So if you haven't typed it in yet, find the answer. You're going to use your caret, that right there, but then you need to hit over with your arrow. Okay, so when you show work, the minimum amount of work that you need to show is what I wrote in blue. So the minimum amount of work would be that you plugged in the 3 into every term and you showed that, and then you have the answer. That would be the minimum amount of work that you need to show. That's the minimum amount of work. Okay, there are 2. Try it on your own. So try them on your own. Make sure you show me the minimum amount of work. Okay, so I put the minimum amount of work on the board, and I put the answer on the board. You check, see if you have questions. Everybody have a question? Okay, so everything that we've done so far is totally doable, isn't it?
Of course. Yeah.
No, we're not to the hard stuff yet, don't worry. Okay, so I'm going to pause this video so we can do some dancing. Alright, so what we have is a chart, and this is not necessarily a chart that you have to memorize, but you have to know it. But you kind of just figured it all out together. This is just going to be written with weird, fancy mathematical language that I'm going to explain right now. So here we have every odd degree polynomial. This is not exactly what it looks like. This is just kind of a sketch that shows that it will look sort of like that shape. Okay? Now what we are doing is we're talking about end behavior. So that means what is happening at the very ends. The left end and the right end. That's what we're talking about here. So you will see on every single one of these, the second part of what it says here, the second part is the same for all 4 of these. they always say, for this side says X, and then there's an arrow, which I'm gonna write down the meaning in just a second. I'll write down the words so just a second. But every single one of them says X arrow negative infinity, and then on the right says X arrow positive infinity. Every single one of them. The left side says X arrow negative infinity, and then right side says X arrow positive infinity. Every single one of them says that. So that would be something that you can memorize, but it's easier to memorize if you know what it means. So I'm going to write what this means in words. This says f of x, and then there's the arrow. That means the function, or f of x we know as the y values. And then the arrow means approaches. And then the next thing means positive infinity. I figure you guys knew that already. And then as x, and then again the arrow means approaches. Negative infinity. So the arrow means approaches, goes towards, gets closer to. So reading that out loud, we say f of x approaches positive infinity as x approaches negative infinity. But again, f of x just means y. So if the y values are approaching, I know, stuff's fun, isn't it? If the y values are approaching positive infinity, that means the direction of this graph is going up. And down. And if the x approaches negative infinity, that means to the left. So we're saying as we go to the left, the graph goes up. That's what this is saying. So over here, when I see as x approaches positive infinity, that means that it is going right. And then on the top, where f of x, which is y, approaches positive infinity, then the graph is going up. So this is a chart which you could refer to, but you're not going to be given this chart on an assessment. So you just kind of have to know what it means. Notice we always talk about the y's first, and the left side is where x goes to negative infinity. The right side is where x goes to positive infinity. So here's an example. Describe the end behavior of the graph of f of x equals, we've got negative 0.5 x to the fourth as the leading coefficient. So the negative leading coefficient and then the degree are the pieces of information that you need to write down so that you can answer this question. The degree is 4, which tells me even. The leading coefficient is negative 0.5. That's negative, but I don't know why I wrote the word negative. But okay, so it's even. What kind of shape is it going to have? If it's even, both ends are going to go up. But then there is a negative coefficient in front, which says both ends go down. So we know, super rough, this is probably not what it looks like if you graphed it on a calculator. We know that it somewhat looks like that. There might be funny things happening in the middle, I don't know. But I know the very ends are going down. So for the left side, we're going to say that f of x, which is the y, approaches something as x approaches negative infinity. That's the left side. Is this answer on your graphing calculator? Or are you just graphing it to see it? Okay. Are you going to be able to answer the question, though? That's what I'm worried about, that you're going to miss how to do it. So the left side, what are the y values doing as we go to the left? So how do I say that? It approaches negative infinity. So that would be the left side. And then over here on the right side, we always start with f of x approaches something as x approaches positive infinity. That's how you always start it. So then you ask yourself, what is the graph doing on the right side? What are the y values doing on the right side? What is this doing? Down. So we say to negative infinity. What'd you say? Oh, how do you draw an infinity symbol? It's like a sideways 8, but I make my 8s with 2 zeros. That's how I make my 8s. But it's like a sideways figure 8. I just think it takes too long to draw. Sideways figure 8, like that? Yeah. Okay. There is a try yourself. There is a try yourself. Go ahead and try yourself. So the leading coefficient is positive and the degree is odd. So we should know that that graph looks something like that. That's a rough picture. I don't know exactly what it looks like, but it doesn't matter. All you need to know is what the ends are doing. So we need to write about the left side and the right side. So on the left side, we always write f of x, which is the y values, approach something as x, oops, that's what I did there, as x approaches negative infinity. As x approaches negative infinity is telling me we're going to the left. So what are the y values doing when we go to the left? So they're going to negative infinity. And then on the right side, we start the same way. F of x approaches something as x approaches positive infinity. And what are the y values doing? What are the y values doing as we go to the right? So we write positive infinity because they're going up. So the thing that I would guess would be the most challenging part about this is not written in words, but it's written in symbols. So you need to practice it over and over again so that you understand the symbols. You remember what they mean. Okay, next one. We're going to graph these. We're going to eventually be graphing this completely by hand. But we're not there yet because we haven't learned the whole chapter. So what we're going to graph by hand right now is the y-intercept and figure out the general basic shape of the graph. So how do we find the y-intercept? That is a review from everything we've done in this class so far. We make x 0 in the equation, make x 0. And what do you get for y? Negative 30. Okay, and then with our leading coefficient and our degree, Leading coefficient is -1, and our degree is 3. So it's negative and it's odd. So the general basic shape, if it is negative, when we go left to right, if it's negative when we go left to right, which direction is this graph going? Is it going uphill or downhill?
Down.
Downhill, this is negative. So it's going to generally look something like that. So we know a basic shape. That is the part that I would say that you should be able to do on your own so far. But everything else we haven't learned. So at this point, go ahead and type it in your graphing calculator. Remember, if your window is not a good window, we can hit what? Zoom 6. That would fix your window. You can definitely see the general shape, but when you have a graphing calculator and you're asked to graph something, it better be accurate. So where can we find accurate points?
The zeros.
Ooh, yeah, you know what? Totally, but you guys are getting way ahead of what I'm asking. I'm asking even more basic. Let's go to table. Yeah. You totally can do the x-intercepts and the zeros and the min and the max. You can do all that stuff right now. I don't want you to take all that time. Let's just go to the table and plot some points that fit. So how do we go to our table? Second graph, right? And if your table is not a window that you like, you can arrow up or down, or you could go to table set and jump to whatever you want. Is anybody's table just way off? You can go to table set, you can do second window, and tell your table to start at whatever number you want it to, and account by whatever number you want it to count by. Okay, I'm gonna go to the paper where you guys have the graphing calculator in front of you. Somebody tell me an ordered pair that is on this graph. -2 what? 3. What's another one? -1. -4. 1, 0. And then what's 2? 2, -1. And then after that, it's off our graph, right?
Yeah.
And then you have the graph in front of you to just kind of sketch it. Super basic. Whoop. Just kind of sketch what it looks like by using your graphing calculator. And it's not perfect, but you shouldn't be looking at my paper. You should be looking at your graphing calculator and copying what you see. Zoom negative. Oh, what? Go up. But your window's like zoomed out pretty far. If you hit zoom 6, your graph will look more like mine did. If you have that one done, start working on the second one that asks for same stuff we just did. If you have that one done, start working on the second one. Make sure there are arrows at the end of your graph because it does go on forever. So you need to imply that on your graph when you copy it on paper. So what'd you find first? The y-intercept, which was at 0, 4. Good. And then we want to look at the leading coefficient and the degree. Leading coefficient is what number? 1. So it is positive. The degree is 4. So it is even. Positive and even, what general shape do we have? And it might be W-like, or it might be U-like. We just don't know until we graph it. So go ahead and type it in your graphing calculator and go to the table. I do what? Okay, to get the exponent faster, to get the exponent, you hit X, and then you hit that caret button that is under the clear, that up caret thing. Yeah, that'll get you whatever exponent you want.
Should I change?
But these were just all right, somebody give me some points. What do we got? Do we have a -2 that fits?
-2 is 12.
Okay, so no. How about -1?
-2.
All right, how about 1?
0.
How about 2?
-4.
And then after that, it's off the graph, right? 22. Who's got their graph handy? You do? Yeah. Just said on the recording. So when we go to connect those, we should make it look something similar to this W. Yeah. Okay. Something like that. And I'm not looking for perfection yet. We'll get there. As long as you can find your x-intercept and know the basic shape, you'll be fine on those. Are we doing okay? How are we doing? Okay. Okay. Example 5. We're going to sketch a graph, but we really don't know all the information. We only know what they've given us. You'll see that it says f is increasing when x is less than 0 and x is greater than 4. F is decreasing when x is between 0 and 4. Anytime that you see increasing and decreasing, when you see f is increasing and f is decreasing, the function is going up and the function is going down. Anytime you see that, these two, they have to do with the max and the min on the graph. Do you remember what a max is? Remember, the max would be where it has a top point. And what's a min? Where it has a bottom point. Right. So this is going to have 2 of them. Can it have 2 maxes? Not if it only has 2. If it only has 2, it can't have 2 of the same thing. It can't. It won't. So we know it's going to be one of each. So what I'm going to do with my graph, when I see things that have to do with max and min, I'm going to separate my graph by putting a vertical line where x is 0 and where x is 4. I'm going to kind of separate it into chunks. Because I know that the graph is increasing when x is less than 0. So here is where x is equal to 0. Here is where x equals 0. Here is where x equals 4. So where x is less than 0, the graph is increasing. That means on this side of that line, the graph is going to be going up, increasing. It also says that it is increasing when x is greater than 4. So that would be all the way over here where x is greater than 4. It is also going up. And then in between, when x is between 0 and 4, the function is decreasing. So the function is going down in between. So if I were to connect my notes on top, if I were to connect those, can you see the basic shape that is starting to form? So at x equals 0, is that going to be a maximum or a minimum point? That's going to be a maximum point. And at x equals 4, that's going to be a minimum point. You can just see that by using the increasing or decreasing. Increasing the way that you read left to right. Decreasing the way that you read left to right. Okay, the second portion. All right, I'm just going to make one more note here. I said it, but I didn't write it. Make vertical lines. Just to help you know what to do when you do this yourself. Okay, the second part. Here we're talking about if f of x is greater than 0 or f of x is less than 0. What that's going to mean for the graph is that the graph is above or below the x-axis. If the function is greater than 0, it's above the x-axis. If the function is less than 0, it's below the x-axis. I'm going to represent those numbers with points on the x-axis. I'll put those as points on the x-axis. So this says f of x is greater than 0 when x is between -2 and +3, and when x is greater than 5. So I'm going to go to -2, +3, and 5. And then it says it's lower than 0 when x is -2 or between 3 and 5, which I've already put those dots on the graph at -2, 3, and 5. So now we just have to think about it. It is less than 0. It is less than 0. That means below the graph, below the x-axis, when x is less than -2. So over here. Then it is above the x-axis between -2 and 3. Okay, so I'm going to start, if you guys watch just for a second here. I'm going to start going above the x-axis, but what happens when I get to this line? That is a maximum, so I have to start going down until I get to that point, which is at 3. And at that point, it goes below the x-axis. And I continue on until I get to this line. And what's that line tell me? That's a minimum point. So I need to start going up again. Then it has to pass through the x-axis again at that third point. There's a lot of things to think about for this. Take your time, use your notes. Go watch this video again if you've forgotten how I explained it. Okay? Last example. Last example. By the way, on this example, I did not know how high up to go, and I did not know how low to go. So that's just sketching. I did know it passed through at the red dots, and I did know there was a max and a min at the blue lines, but that was all I knew for sure. Okay, this says the estimated number V in thousands of the electric vehicles in use in the United States can be modeled by the polynomial function, where T represents the year with T equals 1. What are you talking while I'm talking? You may read this on your own. What's T represent? No, T represents 1, which corresponds to 2001. T represents all of the years. Use a graphing calculator to graph the function for the interval 1 less than or equal to t less than or equal to 10. Describe the behavior of the graph on this interval. Okay, So you're gonna go to your graphing calculator and you're gonna type in that function. How are you gonna do that when it says t? You're gonna make it x. That's right. So wherever you see a t, it's really an x. Type it in. But don't hit graph because it's not going to show up yet. Or it might, but not what we want to see. Go ahead and type it in. Why aren't you typing an X? Why aren't you typing an X? No, this is T plus 1. Yeah, they're telling you that T represents, instead of 2001, we're using 1. That's just how it represents on the graph. Or your numbers, you're not going to use the number 2001 for the first year. But the function you still type in with a variable. Everybody types it in with a variable. With X. Everybody types it in with an X. Check the people next to you. So I don't have to check everybody's calculator. Make sure they give an X. You're not in the right place. Talk to the people next to you. You're not in the right place. Type it in. All right. How do we know what window to create? How do we know the window to create? It tells us. Partially. You see right here, it says graph the function for the interval 1 less than equal to t less than equal to 10, but we just said t is the same thing as x. So I just changed that to x. This is our x min and our x max on our window. So how do we know the y min and the y max? What we're going to do, ready? Let's do it. To find the y minimum and the y maximum, we already know the x min and the x max that was given to us. To find the y min and the y max, go to your, I had to turn it on, hold on. Go to your table and look at your table when x is 1. And at your table, when x is 1, y is 18 point something. How about when x is 10? 58 point something. 57. So that would be the y minimum and the y maximum. But it doesn't have to be perfect. You don't have to type in 18.584. How about we just type in 18? And instead of 58.57, how about we just type in 59 or 60? Just make it a little easier, type in. So we can see the graph. So our y minimum, we're just getting from the table. We'll make our y minimum, what did we say, 18? And then our y maximum 60. So I go to window, and I'm going to change my window. You don't even have to do the y stuff if you want to. You guys, some of us are having different numbers in our table than I had. That means you've typed your equation in wrong. So you go back, and I know there's like a lot of decimals and numbers. It's easy to make a mistake. I'm going to hit graph so you can kind of see if your graph looks like mine, if you followed what I did. Okay, then the next thing that we are doing is we're going to answer a question. So read question A, I'll go over it in a second. Some people are retyping in their equation right now. Read question A. I don't know if you can answer it yet, but start thinking about what it means. Oh, what did I send it to? Did you answer the question?
Are you okay?
I'm gonna take a screenshot of this so that you can see it. Okay, guys, this question that we're answering is something that we did in chapter 1. No, we did not do so hot in chapter 1. So it's coming back again. If you didn't learn it the first time, let's learn it better the second time. We're going to describe the behavior of the graph. When you describe something that has to do with a real life situation, you use words like electric cars and years. The X and the Y values, what they represent. So you're going to use words when you're describing. So what is happening in this graph? As the years go on, what's happening?
Going up.
Oh, I know the graph's going up, but use words like electric cars.
Electric car. Great. I'm so good. I don't know.
Well, it is up here. This is I'm sorry, it says electric vehicles, not cars. My bad. The estimated number of electric vehicles in use in the United States.
4 electric vehicles are being used.
Okay, so you might say,
Use of electric vehicles.
the number of electric vehicles being used in the U.S. increases from 2001 okay, so it's increasing, and it's not just straight increasing the whole time. It's increasing till about when? About here maybe? What years? 2001, 2, 3, 4, 5, 6? Maybe to about 2006? Then it's going to stay constant. It's going to kind of go, I mean, it increases a little bit, but it stays constant until about maybe around here. What, 2009? When it starts to increase again. So the way that you describe this should not be word for word the exact same as every single person, because you might have a slightly different way that you look at it, and you might use different vocabulary. But that's what they're looking for. So it's something to model. Isaac, are you okay, or do you need rubber? Okay, you may stand up. You may not sit in the class. That is disrespectful. You may stand up if you're tired, or you may sit up and participate. You may now put your head down. Okay, the second question is another thing that we did in chapter 1, and it's been a while, and we didn't do so hot first time, so we need to go over this again. What is the average rate of change? That means from start to finish, what is the average change? If I took a line and I connected the first point and the last point, what would be the average rise over run? Ooh, what am I talking about? We need to find the slope of that line. So remember the slope formula is y2 minus y1 over x2 minus x1. And our first point is 1 comma 18 point, I don't remember. Thank you. And then our last point is 10 comma 58.57. So we're going to find the slope in between those points. And 58.57 minus 18.584 over 10 minus 1. So that's 39.986 over 9, which is approximately 4.443. But in the context of this situation, what does that mean? There were, is it really just four cars?
Is that
Right. So 4.443 thousand. More electric vehicles. In use per year. That's how many more they are being used per year. Again, if you're asked to describe things, you're writing in words, and it has to do with a real life situation, not just things like, the slope is 4. That's not what we're looking for here. We're looking for a description. Okay, the last one, we're just going to talk about this. Do you think this model can be used for years before 2001? It didn't exist before 2001?
Maybe. Who knows? That's a Google question.
That would be a Google question. When was the first electric car around? I think
Probably earlier.
earlier, but let's think of another reason. Go to your calculator. Go to your calculator and go to years before 2001.
Wow, -221. Oh my goodness.
Is that possible that we could use this model to go back to like 1999? Max, are you listening to the question? We go back to the year -1, which is 1999, and say, oh yeah, there were -29,000 cars being used. That's not possible. So I would say, no, we can't use this model because we can't have negative cars. No, because there would be negative cars. So no. How about after 2010? Possibly, maybe. You think it's going to keep increasing?
Yeah, but not as steep as that.
Well, is there a push in our country to get rid of gas?
Yeah.
And to do that, we're going to have a lot more electric vehicles. So maybe. Of course, it's a prediction. It's not what's really happening. So we're not sure. All right, that's it. Go grab your computers. What is this, 4.1? Big Ideas says that there is a thing happening at 9 p.m. tonight. I don't know if that's going to force it that where you can't use the thing anymore. I don't know. 9 p.m. tonight, they're doing like an update. So I would suggest getting your math homework done before 9 p.m. And you got time to start.
I wasn't so